In a previous lesson, we introduced spherical mirrors and the terms related to spherical mirrors. We have also studied the image formation by a plane mirror, and by drawing the ray diagram, we get an idea of the properties of the image. In this lesson, we'll draw the ray diagrams for objects placed in front of spherical mirrors and also study the properties of the images formed. In all our ray diagrams, we'll consider that our object is of finite size, and we call such an object an extended object because each small part of the object acts like a point source. From every point source, an infinite number of rays originate. But in order to draw a ray diagram, locate our image and find the size of the image, 2 rays are sufficient. If we use more than 2 rays, our ray diagram will look messy. Thus, it is convenient to use 2 rays emanating from a point. The intersection of 2 rays gives us the position of our image, and we can choose any 2 rays to locate our image. But the 2 rays are chosen in such a way that it is easy to find the direction after reflection from the mirror. Before we start to construct ray diagrams, let us first get our basics strong. The figure in front of you is a concave mirror, and first we'll mark the pole, focus, principal axis and center of curvature. The point P is the pole, point F is the focus, and point C is the center of curvature, and this line is called the principal axis. Now consider a ray parallel to the principal axis falls on the mirror. Applying the law of reflection, angle of incidence is equal to the angle of reflection. We find a ray after reflection passes through the focus. Now, similarly for a convex mirror, ray parallel to the principal axis on extension passes through the focus. Thus we can say a ray parallel to the principal axis after reflection will pass through the principal focus in case of a concave mirror, or appear to diverge from the principal focus in case of a convex mirror. Now consider a light ray passing through the principal focus of a concave mirror. After reflection, the light ray becomes parallel to the principal axis. Similarly, for a convex mirror, if the incident ray on extension passes through the focus, the reflected ray will be parallel to the principal axis. Thus, a ray passing through the principal focus of a concave mirror, or a ray which is directed towards the principal focus of a convex mirror after reflection, will emerge parallel to the principal axis. For a concave mirror, if a light ray passes through the center of curvature, it is reflected back along the same path. Similarly, for a convex mirror, if the light ray is directed in the direction of the center of curvature of the convex mirror, it also reflects back along the same path. Thus, any light ray passing through or directed towards the center of curvature is reflected back on the same path. A light ray which falls at an angle to the principal axis at the pole of the mirror follows the law of reflection. For this ray, the angle of incidence is equal to the angle of reflection, and thus we get the reflected ray. In all the cases discussed, the laws of reflection are valid. Now, let us construct ray diagrams for a concave mirror. Consider the first case when the object is kept at infinity. Draw 2 rays parallel to the principal axis. After reflection, the rays meet at the focus. The place where the 2 rays meet, we get an image. Thus, the image formed is real and inverted. The image is highly diminished and point-sized. Now, place the object beyond the center of curvature. Draw the first ray parallel to the principal axis. This ray, after reflection, will pass through the focus. Draw the second ray passing through the focus. This ray, after reflection, will be parallel to the principal axis. Thus, we get an image which is formed between the center of curvature and focus of a concave mirror. The image is real and inverted, and the image is diminished in size compared to the object. Let us now place the object at the center of curvature and draw the first ray parallel to the principal axis. After reflection, this ray will pass through the focus. Now draw the second ray passing through the focus after reflection, which will become parallel to the principal axis. Thus, the image we get is real, it is inverted, it is formed at the center of curvature and equal to the size of the object. Let us now place the object between the center of curvature and the focus. Draw the ray parallel to the principal axis, which after reflection will pass through the focus. Draw the second ray passing through the focus, which after reflection will become parallel to the principal axis. The image we obtain is real, is inverted, is larger than the object and formed beyond the center of curvature. Now, let us place our object at the focus and draw the ray diagram. Draw the first ray parallel to the principal axis, which after reflection from the concave mirror is going to pass through the focus. Draw the second ray directed towards the pole of the mirror, which after reflection is going to become almost parallel to the first ray. Therefore, our image is going to form at infinity. Our image is going to be highly enlarged and it would be real and inverted. Now, if I place the object between the focus and the pole of the mirror and draw the ray diagram, the first ray being parallel to the principal axis, which after reflection passing through the focus, and the second ray being incident at the pole, and the reflected ray looking like this. Now, since the rays are not meeting, but if I extend the rays beyond the mirror, I see that their extension meet. The image I get is a virtual image. That is, the rays don't actually meet but only appear to meet. Thus, the image is formed behind the mirror, it is enlarged, virtual and erect. The table here shows a summary of the position and properties of the images formed by a concave mirror when an object is kept at various positions. This table is made just for your reference. Don't memorize the table, construct the ray diagrams yourselves and see whether you are getting the same result or not. Now let us replace the concave mirror with a convex mirror and see the image formation by construction of ray diagrams. When an object is placed at infinity, the rays parallel to the principal axis fall on the convex mirror. And if we extend the reflected rays behind the mirror, the rays meet at a focus of the mirror. Thus, the image formed is at the focus. It is virtual, erect and highly diminished. Now, let us place the object at a finite distance from the convex mirror. Draw a ray parallel to the principal axis. The reflected ray on tracing back is directed towards the focus. Draw the second ray in such a way that on extension, the reflected ray passes through the center of curvature. Thus, the position where the extended rays meet is the position of our image. The image formed is between the pole and the focus. It is virtual, erect, diminished, and formed behind the mirror. The table shows the summary of the position and the properties of the images formed by a convex mirror. So far we have seen the image formation by both convex and concave mirrors. Now let us see what can be the possible use of these mirrors. The concave mirror has many uses. They are commonly used in torches, searchlights and vehicle headlights. Let us see how. The bulb is placed at the focus of the mirror, and we know when light rays from the focus reflect from the mirror, they travel parallel to the principal axis. Thus, we get a parallel beam of light. Concave mirrors are even used as shaving mirrors to get an enlarged image of a face. As we have seen, when an object is placed between the focus and pole of a concave mirror, we get an enlarged image. They are also used by dentists to get an enlarged image of the patient's teeth. Large concave mirrors are used to concentrate sunlight to produce heat in a solar furnace. You must have seen objects in the mirror are closer than they appear written on car mirrors. So what do you think? Which type of mirror is it? Is it a convex mirror or a concave mirror? It is a convex mirror. Convex mirrors are commonly used as rear view mirrors in vehicles and are fitted on the sides of the vehicles, which enables the driver to see the traffic behind him. Convex mirrors serve as excellent rear view mirrors because they give a diminished and erect image of the object. Convex mirrors are curved outwards, due to which they have a wider field of view, which enables the driver to see a much larger area compared to a plane mirror. So let us quickly recap what we learned in this lesson. We learned to draw the ray diagrams for objects placed in front of both convex and concave mirrors, and we also saw the practical applications of both the mirrors.